Now we also have some special factoring patterns that we want to learn to recognize. And the first one is called the difference of perfect squares. And that's always when I have some number squared minus another number squared. It will always factor into the square root plus the square root and the square root minus the square root. Note, this is only for subtraction, only for difference. It does not work for addition. Okay, so make sure that you only are using this for subtraction. It does not work for addition. So what I want to do is I want to think about this as really x squared minus 3 squared. So then the x is my a, the 3 is my b, or the square root of x squared is x, square root of 9 is 3, and the same two numbers with a plus sign. Now why a plus sign? From a typical trinomial, we're missing that x term. Well, the reason we're missing it is it was 0 times x, and we don't write 0. If you check your outside and your inside terms, you'll see that you get 0x. Those opposite signs cause that middle term to disappear, which is what you want. We can have perfect squares that have coefficients in the front and powers that are higher than 2. So 9 is a perfect square. And if I think about, I'm going to pull the k off here to the side, k to what power squared would still be 6? Well, remember, x to the nth to the m, we multiply power to a power. So that means this is 3. 3 times 2 would be 6. So I've got k cubed squared, that's my perfect square, minus 4 squared is my perfect square. So my first term is going to be 3k cubed minus 4 and 3k cubed plus 4. So FOIL it and you'll end back, if you ever want to check, if you FOIL, you'll end back to the original. Because foiling and factoring are opposite operations. So 3k cubed times 3k cubed is 9k squared, because remember, x times x to a power times x to a power, we add the exponents. Power to a power, we multiply. And our middle term drops out. We have another set of special factoring pairs, and this works for the sum or the difference of perfect cubes. So if I have a sum or difference of perfect cubes, this will always work. And so if I have a cubed plus b cubed, it will always factor into a plus b times a squared minus ab plus b squared. And if I have the difference of a cubed minus b cubed, it will factor into a minus b, a squared plus ab plus b squared. So it's just a matter of identifying your a and your b, and then following and being very careful with the signs. Now, we talked about in the volume unit, in the similarity with the volume, it's helpful to learn your perfect cubes. When I see a binomial and identify one as a cube, I automatically check the other. So this is x cubed plus 6 cubed. 216 is 6 cubed. So I'm dealing with the plus situation here. And so I have x plus 6 times x squared minus 6x plus 6 squared, which is 36. And so that is how you handle the sum of perfect squares. If we jump down to homework number should be 44. I'll just rewrite 44. Look at number 44, which is x cubed minus 125. So this is the difference of perfect cubes because x cubed minus 5 cubed, 125 is 5 cubed. So if we scroll up so we can see the rule, it becomes x minus 5 times x squared plus 5x plus 5 squared, which is 25. So those are the sum and difference of perfect cubes.